In our last video, we gave an introduction to GPS using a very simple Hello World example. This included a primer on GNAT projects, editing, and compilation. This time, we'll show you how to use GPS to navigate and understand a calculator example program that we ship with GPS. The GPS installation includes sample programs that demonstrate GPS functionality. In order to work on these programs without modifying the originals, we'll make a working copy. These samples can be found in the GPS installation under Share, Examples, GPS. One of these projects is used for the GPS tutorial, and that's SDC, which stands for Simple Desktop Calculator. I'll load it here using Project, Open, and then navigate to the example in the copy that we just made. The Simple Desktop Calculator is an implementation of a reverse Polish notation calculator. It maintains a stack of values. You can input values to push onto the stack, and you can perform arithmetic operations with the values on the stack. If you try to build it, you'll notice that the program comes laced with several errors, and the whole point of this is so that you can learn to use GPS to fix these problems. For this video, we'll use an enhanced version of SDC. The enhanced version is able to do some simple matrix arithmetic and uses C code to do so, so it's a mixed language application. This project is located right next to the simpler SDC example. We'll open, navigate up one level, then back down to Demo, then open demo.gpr. One of my favorite things to do is to plug things in and turn them on before reading manuals. So that's what I did with this program at first. First, we'll build the main executable. Alright, we get a bunch of coding style warnings. This tells us, among other things, that we're compiling this project with style checks turned on. If we open up project properties for demo, go down to Ada compilation switches, and click on style checks, we can see that several of these checks are selected. So to fix these style checks, you can do several things. There are small wrenches in the locations view, and there are small wrenches next to the line numbers in the editor that you can click on to use GPS's autofix feature. If you want to fix things manually, you could just use the spacebar and delete keys to adjust white space, or you could employ GPS's automatic indentation feature by using the Tab key. Since we can see that all of these style warnings have to do with indentation, another thing we could do is to merely select the whole editing buffer with Ctrl-A and hit Tab. Alright, let's try building this again. Alright, there are more problems. These are all just warnings, but let's get rid of them all the same. It looks like all we need to do is include a system header. So I'll add the hash include standardio.h to the top of the file. And let's try building this again. Success! Now let's run it. In the run view down below, we have input and output to this SDC execution. So I'll push a 1 onto the stack, then a 2, then say plus to add. Now, what I had expected was for the program to tell me that 3 was the result of 1 plus 2. So what's going on? Furthermore, I wasn't sure how to quit the program. I tried Control-C, Control-D, Control-Z, I tried Q, buy, and exit, and some other things which just didn't work. So what I did before to terminate the program was to do it brutally by closing the run view. Well, let's look at how everything's supposed to work. SDC.adb is the main program. And as soon as you invoke it, you can see that the first thing it does is print out the initial message. There's a bit of command line argument processing that we'll just ignore. And here's our main loop. If you ignore the exception handling, you have an infinite loop that calls process next. If you hover your mouse over any entity in the editor, you get a tooltip that's pretty informative that tells you what that thing is. Tokens.process is a procedure. This function returns a token, and that token is passed as an argument to the procedure. While holding the control key down, clicking on process will get me to its declaration. And then control clicking on the declaration then gets you to the body. So it looks like we have 3 kinds of tokens according to this case statement: values, operations, and instructions. Values would be numbers that you push onto the stack. Operations would be arithmetic operations like plus and minus. And instructions. Well, what instructions do we have? Let's take a look at the call to instructions.process. There are 3 instructions here: clear, print, and quit. And this all smells like an enumerated type. Well, let's check out the quit entity by control-clicking on it. Yep, we're back at the spec for the instructions package, and there's our enumeration. And there's a function here that converts strings to enumerations. Okay, this use of instruction tick image here is the big clue. For all instructions, if the string that we're given matches the name of an enumeration value, which in our case can be clear, print, or quit, then return the enumeration that corresponds with that spelling. We'll go back one step by using the back button in the toolbar. Now, I don't know who calls read. Well, we could find out by right-clicking on it and asking GPS what read is called by. But really, what this all suggests is that perhaps just by typing in either clear, print, or quit will make the calculator do more interesting stuff. Well, we could try it out. Using the Shift F2 hotkey, I'll run the program again. Push a 1 onto the stack, push a 2 onto the stack, add the values on the stack. Now, let's try some of those commands. I'll bring up the sources for reference. Sometimes, instead of control clicking, I use a right-click contextual menu to directly navigate to either a spec or a body. So, according to this, the print command should display the contents of the stack. And it does. The clear command should clear the stack, and it does. And the quit command quits the program. Not bad. Earlier, I figured out how to input matrices and do some simple arithmetic with them. The matrix handling in this program, as it turns out, is super simple. It can only perform addition and multiplication on 2x2 matrices. Let's start the program again. To input a matrix, first you take 4 values and push them onto the stack. These values will be used to create the matrix, left to right and top down. The hash operation will pop those 4 values off the stack, create a matrix, and put a matrix back on the stack. The way this program interprets input, you can enter a bunch of tokens on the same line separated by spaces. I'll enter an identity matrix, which is just ones along a diagonal. Entering an asterisk will multiply these values. And basically, because we multiplied a matrix by 1, or its identity, we get the same matrix back. You could flip the matrix as well using ones along the other diagonal, or the anti-diagonal. Multiplying by this matrix will transpose the values. Now, one thing that's been bugging me throughout this demo has been this extra garbage that seems to be printed every time I want to print a matrix. To see where this is coming from, I'll dig into the program using the GPS debugger in the next video, so stay tuned.